Alright, so in section 14.2, what we're going to be looking at is taking the derivative of a function with more than one variable. So, just to give you an idea, if we have a cost function, and the cost function depends on two things. Let's say it depends on the cost of the product as well as labor. Okay? Then, what does it mean when we take the derivative with respect to only p? What that means is that we keep labor constant. So what we want to do is we want to see how does our cost change as our price changes, which means that we're going to keep labor constant. So we'd still have our employees making the same amount of money, bringing the same amount of hours, but we would change the price of how much it costs to actually make the item. Now, if we took the derivative with respect to labor, okay, what that means is that we're keeping the price constant, but we're changing the cost of labor. So we keep the price it costs to make this item constant, but then we're changing the labor, right? So we're either adding the amount of hours that somebody works, or we could be changing the amount that we pay them, right? So remember, on this one, we're changing the cost as we change the price. We're keeping labor constant. On this one, we're keeping the price constant while we change the cost and we change the labor. So we're going to let z equal x cubed plus 5x minus 2xy cubed plus 5y. Now we want to find the derivative of z with respect to x. That's the same thing as finding z sub x. Remember, what this means is that we're going to keep y constant. What I mean by keeping y constant is that we're just going to treat it like it's just a number. So, for example, if y is just a number, what's the derivative of y then? It would be 0. So, when we take the derivative of z with respect to x, alright, so the derivative of x cubed would be 3x squared, because we're leaving that as a variable. The derivative of 5x would be 5. Now, if we're treating y cubed like it's just a number, what happens to a number when you're multiplying it by a variable when you take the derivative? Well, it just hangs out in front. And then the derivative of x is just 1. Plus, and then the derivative of 5y squared, remember, we're keeping y constant, so what's the derivative of a constant? It's 0. Now, on the second one, we're going to find the derivative with respect to y. So this time we're going to treat we're going to treat x like it's a constant. So the derivative of x cubed, remember, we're just treating it like it's a number, so that would be 0. The derivative of 5x, remember again, we're keeping x constant, so we're pretending it's a number, so that would also be 0. Minus, now, remember, that's going to be 2x in front, times the derivative of x cubed, which would be 3y squared. Remember, we're treating this coefficient like it's just a number. Plus 10y. Great. You're going to want to simplify that when you do the homework. So that's going to simplify out to negative 6xy squared plus 10y. Alright, now for the next one, we're going to be finding second and third derivative, or just second derivatives, but changing the variable. So before we start, we're going to do z sub x, which would be 2x minus 3. And we're also going to find z sub y, which equals 30y squared. Now, what does z sub x mean? What that means is that you're going to find the derivative with respect to x first, and then take the derivative of that function again with respect to x again. So the derivative of this guy would be just 2. Alright, now on the next one, we want to find z sub y. So again, what that means is you're going to take your original function, and you're going to find the derivative with respect to y. So let's see, that's a constant and that's a constant since we're doing it with respect to y, so that would be 30y squared. And then what the second y means is take the derivative again with respect to y again. So the derivative of this guy would be 60y. Now for this one, z sub xy, what this means is find the derivative with respect to x. So that would be 2x minus 3. And then it wants you to find the derivative of that function, but now with respect to y. So notice we don't have any y's here, so every piece is just a constant. So we'd have 0. Same thing if we wanted to find z sub yx, or sorry, z sub yx. Well, we find the derivative with respect to y first. And then if we do it with respect to x, well, we don't have an x here, so that would just be 0. We're going to do one more little example before we go on to the big one. Let's say that we had z equals, z equals, let's say that that equals x cubed times y to the fourth. Okay, then if we found zxy, what would that be? Well, first we find z sub x, which would be, remember, we're going to treat y like a constant, so it just hangs out in front, times 3x squared. Now we're going to take the derivative with respect to y. So remember, now this is going to hang out in front because it's just a constant, times 4y cubed. So that answer would be 12x squared y cubed. The reason that you just let this hang out in front is because, remember, it's acting like a constant. So if you had, for example, 5y to the fourth and you found the derivative, you would just let the 5 hang out in front and then take the derivative of y to the fourth. It's the same idea. All right, very last example is the cost in dollars of manufacturing one item is given by c of x comma y equals 10 plus 2x plus 7y, where x is the cost of 1 hour of labor and y is the cost of 1 gallon of solution. So let's say that we're, I don't know, developing film or something. If labor costs $17 an hour and the solution costs $45 per gallon, what is the cost of manufacturing one item? So let's see, if labor costs $17, so labor is our x variable, so that's going to be our x. And the solution costs $45, so that's going to be our y. So what we have to do here is plug these in for x and y. So we're going to have the cost, 17 comma 45. So when labor is $17 an hour and the solution costs $45 a gallon, our cost is going to be 10 plus 2 times 17 plus 7 times that 45. It will cost us $359 to produce one item. Now what we want to do is we want to find the partial derivative c sub x. So we want to take the derivative of this guy with respect to x. So the derivative of 10 is 0. The derivative of 2x with respect to x is 2. And the derivative of 7y, remember, we're keeping y constant, so that's going to be 0. So that's going to be 2. All right, very last question we're going to answer is we want to fill in the blanks of the interpretation of this partial derivative. So filling in the blanks, it's going to cost, in dollars, of manufacturing one item will increase by, so let's see, it's going to increase by $2 for $1 increase in, so remember, this is C, so the change in C over the change in X. So that means that the cost is going to increase by $2 for every increase of X. So what is X again? X is our labor. So every $1 increase in labor, and if blank is held constant. So remember, since we're taking the derivative with respect to X, we're keeping Y constant. So that means if we keep the cost per gallon constant. Great, all right, that is all I have for you. That's your last video. I'm really bummed that I didn't get to meet you guys in person, but maybe I'll see you around town or maybe in the next class. That would be amazing. All right, take really good care of yourself.